To solve this challenge, we can iterate through the array and keep track of the current streak of alternating elements. Whenever the streak ends, we can calculate the number of subarrays that can be formed from that streak using the formula n multiplied by n plus 1, divided by 2, where n is the length of the streak. Then, we reset the streak and continue iterating. We initialize a variable count to store the total number of alternating subarrays, and a variable streak to keep track of the current streak of alternating elements. We set the previous variable to the first element of the array, as it will be the starting point of the first streak. We iterate through the array starting from the second element, index 1. For each element, we check if it's different from the previous element, previous. If it's different, we increment the streak and update previous to the current element. If it's the same, we calculate the number of subarrays that can be formed from the current streak using the formula streak plus 1, divided by 2, and add it to the count. Then, we reset the streak to 1 and update previous to the current element. After the loop ends, we handle the last streak by calculating its contribution to the count using the same formula. Finally, we convert the count to an I64 and return it. The time complexity of this solution is O(n), where n is the length of the input array nums. Since we iterate through the array once, the space complexity is O(1), as we only use a few constant-sized variables. Oh hi Rustin!